This video today, working with inverse trig functions, is more of a watch and listen and think about than it is a do. So just sit back and put the pen down. You just want to listen to how I describe what's going on here. There are some important concepts we want to get in this particular lesson. These are the inverse trig functions that you already know and have worked with quite a bit. As a matter of fact, every time we needed an angle, we would plug whatever function value, whatever number we had, we would plug it into here, and that would give us an angle for our answer. Well, these inverse functions have other equivalent names. It's the same function with a different name. Instead of sine inverse, we could also call it the arc sine of x, and that means we would be plugging a function value, a number in here, and the result it would give us would be an angle. So we've got an arc sine, an arc cosine, and an arc tangent. But there's something special about these arc sine, arc cosine, and arc tangent functions. They are functions, which means they would have to pass a vertical line test. Okay, let's look at that red curve. Focus your eyes on the red curve. The red curve is just a regular sine of x, like we learned how to graph and we learned how to work with those. And then to find its inverse, we reflect it over that diagonal y equals x line. And so you can see that visually the reflection of everything in red is the curve in blue. The problem with the curve in blue is it's failing that vertical line test in a big way. So the blue curve, it's an arc sine. It says it's arc sine. It's the equation arc sine of x, but it's definitely not a function. And there are softwares that can plot equation, but not equations, but your calculator can't. Your calculator is going to do functions, at least in press the test mode. Okay, so an inverse trig function has what we'll call a limited domain or restricted domain. And the reason it has a restricted domain is because we need it to pass this vertical line test. What does that mean? It means that we can take any one section of this curve. If I were to talk about just this yellow section, well, that would pass a vertical line test. If I talked about just this highlighted blue section, that would pass a vertical line test. If I talked about just the pink section, that would pass a vertical line test. So as long as I can appropriately restrict the piece I'm talking about, I can call it a function. And that's what we're going to do. We're going to be restricting the piece we're talking about. Your calculator will show you exactly where the restriction is. You see, when you try to plot sine of x, you get the entire curve. There's the line of reflection, y equals x. But if you ask your calculator to graph sine inverse or arc sine of x, it's going to plot only this black piece right here. Remember, your calculator can only plot functions, so it's going to, on its own, restrict the domain. And what do we mean by that? Well, we limited ourselves to the part of the sine curve that exists in between minus pi over 2 and pi over 2. And that's the piece on the blue curve right here, that green piece on the blue curve, is the only piece of the sine curve that we reflected over that line y equals x. So my restriction on an arc sine or a sine inverse is that I'm only going to use domains in between minus pi over 2 and pi over 2. Okay, let's look at the cosine function. Same thing is true with the cosine function. You see the cosine curve is graphed here in green. And if I were to take that cosine curve and flip it over that red line, reflect it over the red line, then I would have a curve that wraps all up and down the y-axis, and that curve would not pass a function test. So if I want to limit it to being a function, an arc cosine function, then I'm going to choose this area in between here. You see the yellow highlight in here? I'm going to reflect just that piece of the curve. My inspire showed me just that piece of the curve was reflected. So it starts here, original starts here, ends here, and this number is 0 and this number is pi. So the domain restriction on the cosine inverse or the arc cosine function, in order for it to be a function, is going to be between 0 and pi. And last but not least, we're going to take a look at the tangent function. The tangent function, well, that's the pink one. I graphed the tangent in pink, and you remember that it has asymptotes excuse me, at odd intervals of pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, etc. But what we're going to have to do, if we want our inverse to be a function, we're going to take just this one piece of the tangent curve, the piece that exists in between minus pi over 2 and pi over 2, and we'll reflect just that piece of the tangent over that red line. When we do, we end up with this black curve. So the black curve is my inverse tangent or my arc tangent, and it results from taking only this one piece of the tangent, the piece between minus pi over 2 and pi over 2. So we have a set of rules that you can memorize, or you can use your calculator to look at the pictures and help remind you of this, but you'd have to set up all the axes properly. You might just be better off learning the rules. The restricted domain of the original function, if we start off with f of x equals sine of x, if we use only this piece of it, then we will have a function for sine inverse or arc sine. And this is going to become handy when we start talking about getting doing our evaluations, which we will do a few today. If we start off with f of x equals cosine, as long as we only take the piece in between 0 and pi, then we can say that arc cosine will be a function. And we will be working with these functions, so we're going to have to kind of memorize these restrictions. Domain of the tangent, if we take only this piece of the tangent function, then we will have a function for the arc tangent. Okay, we're going to see how this works. Take a look at this example down here. If I need to find the arc sine of square root of 2 over 2, or sine inverse of square root of 2 over 2, well, sure, you could pick up your calculator, you could type it in, but you're going to have to show the work, because as you unfortunately have heard too many times before, it's not about the answer, it's about how you get there. So let's begin by looking at square root of 2 over 2. You already know we could actually draw that out, and we could use the fact that sine square root of 2 over 2 comes from the sine opposite over hypotenuse, and so we could draw out a right triangle. We could figure out the legs and use Pythagorean theorem to find any third side. But you should be pretty familiar with this number. Hopefully you know that the sine of a 45-degree angle yields this number, so we shouldn't be surprised when we come up with 45-degree angle out of this. However, we've got a consideration here. We memorize that the arc sine exists for us in between minus pi over 2 and pi over 2. That's on these things I asked you to memorize a little bit higher on the screen here. So if that's the case, then we can only talk about those 45-degree angles or their other quadrant angles in between minus pi over 2, which is yellow down here, going up to pi over 2. So we have to ask ourselves, of these two quadrants that I can consider, between minus pi over 2 and pi over 2, of these two quadrants that I'm allowed to consider, then in that case, which of those two quadrants will give me a positive sign? And I think you all know the answer is quadrant 1. So that's why I'm drawing my triangle in quadrant 1. And I can finish up the problem. I know that my degree measure is supposed to be 45, and in quadrant 1 a 45 is just a plain old 45. So the answer, the evaluation of this, would be 45 degrees. No surprise there. Let's move on to a second example. Find the arc tangent of negative square root of 3 over 3. Okay, we're looking for that angle. Remember, here's a number. We're looking for the angle. It's just like a tangent inverse. And we want to figure out the angle. Well, again, this is a special angle number, so you probably recognize it. Let's talk about the quadrants first. We memorized a few minutes ago that the arc tangent function exists in between minus pi over 2 and pi over 2. So again, we're talking about the possibility of using either of these two quadrants. But hey, that argument is negative. And so we have to ask ourselves, where is the tangent negative? And that only happens in quadrant 3. So that's why my triangle is drawn out in quadrant 3. You could use that triangle if you didn't recognize the square root of 3 over 3, but you probably recognize square root of 3 over 3 as one of your special angles, and that's going to come out to be a 30-degree angle. Well, we can't use the 30-degree angle in this case because we're not supposed to be in quadrant 1, we're supposed to be in quadrant 3. So we would say 360 minus 30 degrees will get us to 330 degrees, and that's going to be our answer to this little problem right here, 330 degrees. Now we're working all in degrees. Should you be given something in radians, then you could convert it to degrees and work from there. A third example here. Oh, well, we just slapped something else into the problem. Let's take care of the arctangent of 2/3 first. And this is one that you probably don't recognize, the 2/3. We haven't memorized that one. So we're looking in the interval again. We memorized tangent is going to be in between minus pi over 2 and pi over 2. So again, we're somewhere in quadrant 1 or quadrant 3, and this tangent's a positive number. That tells us we have to be in quadrant 1. So we'll draw out our triangle in quadrant 1. If the arctangent is 2/3, that means the opposite over adjacent was 2/3. So we'll label our opposite side 2, we'll label our adjacent side 3, we'll use the Pythagorean theorem to come up with a square root of 13 for the hypotenuse. And now I can take all that information and straight away use it to figure out what the cosine is. All I have to do is look in that triangle. I've got everything labeled. Cosine is adjacent over hypotenuse. So we'll just look at the adjacent side 3 over the hypotenuse of 13 and square root of 13. And because that hypotenuse is a radical, we're going to have to rationalize it. So the answer to this entire problem ends up being 3 square root of 13 over 13. Now that's not an angle, nor should it be. You found an angle for using the arctan function, but then cosine of an angle is just a number. So we got a two-step process here, but you can do it all using the single right triangle in quadrant 1. Okay, one we don't have some pictures for ahead of time, so let's walk through this one. We've got, first of all, we're going to find, move this out of the way, we're going to find the arc cosine of -1/2. Let's focus our attention on this. Let's sketch out our 4 quadrants. We know that the cosine is a negative. We have to remember what the domain of the cosine function is. That's something you memorized. That is in between 0 and pi. Well, if 0 is here and pi is here, that means that we have a choice between quadrant 1 and quadrant 2. Well, if the cosine was a negative number, we have to be in quadrant 2. So that's where we're going to draw out our triangle. It says the cosine is equal to a -1/2. Well, cosine is adjacent over hypotenuse. We'll have to use the Pythagorean theorem to figure out what this other side is. So let's say 1 squared plus y squared is equal to 2 squared. Remember, when you're using when you're trying to find the sides of a triangle, do not use the minus signs. So 1 plus y squared is equal to 4. We're going to subtract 1 from both sides. Excuse me, we get y squared is equal to 3, so y is equal to the square root of 3. We know that's supposed to be a positive square root of 3, so I'll leave it positive. It's going up from the x-axis. And we're in quadrant 2. And you can, now, in truth, this is something that you should have memorized, the 1/2, so we know we end up with a 60-degree angle here, but let's go ahead and use the fact that we're supposed to find the tangent when all is said and done. I've got a triangle that's completely labeled. I can look at opposite over adjacent, which is square root of 3 over -1, which gives me minus square root of 3. If you wanted to do it as a two-step process, you could say, oh, our cosine of -1/2. I know that's supposed to be a 120-degree angle because I have a 60-degree reference angle in quadrant 2. That's 120 degrees. And so that's my angle. Now I have to take the tangent of 120 degrees. I switch it back to my reference angle QRS, the sine, the trig function, the angle. I know the tangent of 60 is square root of 3, so I put a minus sign in front of it. So you can get there either way in this case, whichever works best for you. Well, before we end this video, I just want to show you 3 actual Regents exam questions. I'm going to show you this question here. Which graph represents this equation, y equals cosine inverse of x? Well, I think this is actually meant to show a function because both of these pass the function, the vertical line test. This we know is our good old sine curve. This we know is our good old cosine curve. So it's not that, and it's not that. It's got to be one of those two. And how do I choose? Well, the easiest way to choose is to pick up your calculator, go to a graph page, and hit cosine inverse, and lo and behold, it's going to match up to this perfectly. So that shouldn't be too tough for you. When you don't have a calculator, what would you do? Well, if you're doing an inverse function, then what I want you to do is I want you to be reading the y-axis. If we talk about that domain of the arc cosine or the cosine inverse being between 0 and pi, then if you read the y-axis, you'll see that what appears here starts down at 0 and goes up to pi. Okay, we're doing an inverse function, so you're going to read the other axis, and what the numbers that the function appears in between on the other axis should match up. But again, if you have that calculator in your hands, you can just make a picture of cosine inverse of x on your calculator and match that. Let's look at the second Regents question here. Which graph shows cosine y equals cosine inverse of x? Well, that one has to be a y. I'll agree with that one because none of these pass a vertical line test, so I couldn't call any one of them functions. We just talked about the fact that if we read the y-axis, we'll be good to go on these. But because in this question, I think it was a poor choice of a question on the part of the Regents, because of the fact that we're not graphing functions here, well, this exists in between 0 and pi, and so does this, and so does this, and so does this. So really what you need to do is you need to match up the pink piece between 0 and pi to what your calculator will show you is between 0 and pi. And again, like I said, I think this was one of the earlier questions. Really, it's all about working with arc cosine as a function. And then the last question here was more explicit. It says the function tangent of x, we want to define it so that its inverse will also be a function. And so what will be the domain? How can we define tangent of x so that when we do take the inverse is also a function? Well, we're just going to take that one piece of that pink tangent curve, and the piece we're going to take is the piece that exists in between minus pi over 2 and pi over 2.